Hello, and welcome to the 5th episode in our series where we create a 3D rendering engine from scratch. In this episode, we will finally be moving on to texturing our triangles, and our end goal is to make something like this. So I can move around and view it from different angles. And the program will take an object file and a texture file and render something like this. So let's start out with how our program is going to draw triangles from now on. Our program is going to take our triangle and go over every pixel inside of this triangle. It's going to get this pixel's distance from each corner as a percentage and use that information as well as the triangle's UV coordinates, so each of these corners UV coordinates on the texture, and it's going to use the distance information to work out where that pixel belongs on the texture. So in this case, this pixel might be red on the texture. Now it's pretty easy to see how a triangle that is facing the camera will line up to the texture. This pixel goes here and this pixel goes here. But if we were to rotate this triangle at an angle, it's not so easy anymore. So this is why we use the distance from each corner, because we still get an accurate result. We still are able to match up the pixels accurately. So if we get the distance over on this triangle at an angle and we get the center pixel, this will line up to the center pixel on our texture. Now we repeat this for each row on the triangle, and we do this by creating a box that perfectly fits the triangle and then going over every pixel inside this box. Now, if a pixel is inside the triangle, it will add up to 100%, its distances from each corner. But if a pixel is outside the triangle, it will not add up to 100%. So this is why we can determine if a pixel is in or outside the triangle. And if the pixel is outside of the triangle, we won't run this code. We will only run that code if it is inside the triangle. So last time we finished off preparing our program for textures. And in this episode, we will be using this code to finally draw the textures onto our triangles. But before we do this, we need to create a small piece of code that can find the percentage distance from each corner that our pixel is, like we learnt earlier on. So we're going to write here above public form 1, vector3, barocentric, bracket, vector2, p, vector2, a, vector2, b, and vector2, c. And so now we're going to write float d equals b dot y minus c dot y times a dot x minus c dot x plus c dot x minus b dot x times a dot y minus c dot y. And this is going to be equal to double the triangle's assigned area, which will help us work out how far away the pixel is from each corner of the triangle. So now we're going to write float weight 1 equals, we're going to copy this line and put it into brackets and write divided by d. We're then going to copy this line and duplicate it, change this to weight 2. Here we're going to change all of the a's to p's. In this bottom line we're going to change this b to a c, and this c to an a, this c to an a, and this b to a c. And then below this we're going to write float weight 3 equals 1 minus weight 1 minus weight 2. And this is because all of the weights have to add up to 100% or 1. So we can work out weight 3 by taking 100% minus weight 1 minus weight 2. Finally, we can write return new vector 3, weight 1, weight 2, and weight 3. And that's it. And so now we're going to go down here and we're going to write void draw textured triangle, and inside these brackets we're going to write graphics g vector 2 p0 vector 2 p1 vector 2 p2 vector 2 uv0 vector 2 uv1 vector 2 uv2 float 0 float z1 float z2 float z buffer object z buffer lock byte texture int texture width int texture height int texture stride and byte pixel buffer. And so now what we're going to do is we're going to go in here and we're going to write int min x equals math, we're going to write int math dot floor math dot min p0 dot x math dot min p1 dot x and p2 dot x. And so what we're doing here is when we're drawing the triangle, we want to create a little box that perfectly fits the triangle, and then we go over every pixel in this box and draw the triangle. So that way we're not drawing the entire screen just for one tiny triangle. We're creating a little box the size of the triangle and then drawing the triangle. So we're getting the maximum x value, copy this, duplicate it, we'll change this, this is minimum x value, change this to maximum x value, and we're going to change it to ceiling, this to max, and this to max. And then we're going to copy all of this, and we're going to paste it again, We're going to change this to minimum y and maximum y. And then change all of these x's to y's. And yep. And so now we're going to repeat for every pixel inside of this square. Run this whole code. So we're going to write for int y equals min y, and y is smaller than max y, add y. And then inside here, we need to make sure that the square, because the triangle can be like partly off the screen, so we're going to make sure that the triangle is still on, this pixel is still on the screen. So we're going to write if y is bigger or equal to 0 and y is smaller than min y. Oh, no, this should be screen height. Now we're going to do the same thing, but for the x. Let's change this to x, this to x, this to x, and this to x, these two to x, and this y. And then this should be screen width. And so this is going to repeat this code here for every pixel that's on the screen and inside this little box. And so now we're going to get this point that we have on the triangle. So we're going to go over every pixel. We're going to get that pixel and turn it into a screen coordinate, a screen point. So we're going to write vector2 p equals new vector2, and inside here we're going to write x plus 0.5f, comma, y plus 0.5f. And we're adding this because this value is in the corner of the pixel, and so we want to make this value, this point, in the center of the pixel. So we add half a pixel to it. Then down here we're going to write vector3 Barry equals barycentric p, p0, p1, and p2. And so this is going to get our point, our pixels, distance between each corner of the triangle. Now we want to test to see if this point is in or outside of the triangle, because if it's outside the triangle, then we just ignore it, we skip it. So we're going to write if Barry.x is bigger or equal to 0, and Barry.y is bigger or equal to 0, and Barry.z is bigger or equal to 0, run this code. And this is going to ensure that this pixel is inside of the triangle before we run this code. And so now we're going to get the pixel's distance from the camera in camera space using the pixel's distance from each corner of the triangle. And we're also going to be doing perspective correction like we did earlier on, which is just dividing by z basically. So we're going to write float iz0 equals 1 divided by z0. And then iz1 equals 1 divided by z0, and iz2 equals 1 divided by z2. This should be a 1, yeah. And then we're going to write float interpolated invz equals Barry.x times iz0 plus Barry.y times iz1 plus Barry.z times iz2. And then we're going to write float interpolated z equals 1 divided by interpolated inv z. And so now what we're going to do is we're going to check if our new pixel is closer to the camera than the previous. So up here we created two buffers last episode, depth buffer and depth buffer lock. The depth buffer stores how far away every pixel is from the camera, so by default it's set to infinity. And the depth buffer lock ensures that it can only be written to once. You can't have multiple CPU cores trying to write to it at a time. So we're going to go back down here and we're going to write lock. And then we're going to write z buffer lock x, y. And then inside here we're going to write f interpolated z is smaller than the z buffer x, y. So we're basically checking if this pixel is closer to the pixel that's already in the buffer, then we're going to write to it. We're actually going to draw this pixel now. And so in here, we're going to get the coordinates of this pixel on our texture. So the UV coordinates. So we're going to write float u0z equals uv0.x times iz0. And we're going to copy this and we're going to paste it 2 more times. We're going to change this 0 to a 1 and this 0 to a 2 and do the same for the rest of this. Now we're going to copy this whole piece and duplicate it, changing the u's to v's and the x's to y's. Now below here, we're going to write float interpolated uz equals barry.x times uv0 u0z plus barry.y times u1z plus barry.z times u2z. We're going to copy this and we're going to duplicate it, changing this u to a v and changing this u to a v and doing the same for the rest of them. And finally, we're going to write float u equals interpolated uz divided by interpolated inv z. And we're going to do the same for the v. And so what this is doing is this is basically getting the distance from each corner of the triangle, the pixel's distance, like we've done already, and it's perspective correcting it. And then we're looking on the texture and looking on the texture's UV coordinates and taking those distances between each corner in the camera space triangle and looking at those same values on the texture. And that pixel in the texture will be the same as the pixel in the triangle in the camera space. And so this is it. This U and V value is the pixel that we're looking at. And so now we're going to get the actual pixel coordinates inside of our texture. So we're going to write int text x equals math.clamp int, and then we're going to write U times texture width 0, texture width minus 1. And then we'll do the same for the Y. Change this to texture height. And there it is. So we're getting the actual pixel coordinates. And so now we're finally going to get the actual color of our texture. So we're going to write here, color, base color equals color dot from ARGB. And here we're going to write texture and then we're going to write texture Y times texture stride plus texture X times 4, because each pixel has 4 bytes, plus 3. And then we'll do the same but with plus 2. And then plus 1. And then plus 0. And so this is because we're getting the red value, then the green value, then the blue value, and then the alpha value, which the alpha value will be used. So now that we have the base color, this part of the code you could probably apply lighting, such as shadows and all that stuff. We'll most likely not be doing lighting in this series, but this is where you would apply lighting, because now you have the base color, you can manipulate it. And so here we will be now writing to the Z buffer and the pixel buffer. So we're going to write if base color dot A is not 0. So if it's not a transparent object, such as like leaves or something else, then we'll render it. And then inside here, we're going to write int index equals Y times screen width plus X times 4. And this is just getting the index in our pixel buffer. So where in this pixel buffer is this pixel specifically. And then here we can write pixel buffer. And then here we can write index plus 3 equals base color dot A. And then we'll do B base color dot, this B should be an R, so A, R, G, and then B. And so here we're writing to the pixel buffer with our index plus 3 for the alpha, 2 for red, 1 for green, and 0 for blue. And then finally we'll write Z buffer XY equals interpolated Z. So now we're writing to the Z buffer with this new pixel, so that another pixel, when it goes to check if it's behind or in front of the camera, it will have this pixel stored in the Z buffer. So that's it for this part. We can now use it for drawing triangles. And so now what we're going to do is we're going to finally be replacing this part. this full polygon part. So we're going to be writing draw textured triangle e.graphics P1, P2, and P3 triangle dot item 4 triangle dot item 5 and triangle dot item 6 v1b dot z v2b dot z and v3b dot z. Then we're going to write depth buffer and depth buffer lock, and then mesh dot texture width, mesh dot texture height, mesh dot texture stride, and pixel buffer. And that's it. That will take all of this information and draw a triangle to our screen. So if we give this a run, there is our car now with textures. And so that's pretty much it for this episode. We have finally added textures to our 3D rendering engine. In the next episode, we'll be moving on to near plane clipping. So earlier on we created the little camera moving part and the object moving part, and if you were to place the camera, say, halfway between this car or at a funny angle, there would be a glitch sometimes where the triangles will sort of explode across the screen. And so to fix this, what we're going to do is we're going to cut the triangles along the camera's z-plane. So in camera space, a z value of almost 0. We're going to cut it along that and create new triangles along that plane, so that all of the triangles are in front of the camera and properly being rendered. But yeah, that's it for this episode.